Hello my dear viewers and listeners, may peace be upon you. In this video I am going to explain about errors, relative errors, absolute errors and the percentage of errors. How do we measure it and why we need to measure it? Because in our daily life and actually in laboratory, when we measure something, like think about physics lab, we are measuring something, the diameter of something through slide calipers or screw gauge. On that measurement, there might have some mistakes, and these mistakes are called errors. So theoretically, we can say these errors can be two types. Number one, the errors can be systematic. The errors can be systematic, and in other cases, the errors can be random. Now, my question is that when the students of physics will study about slide calipers, screw gauge and measuring some things using these machines, then there are some possibilities of mistakes, and these mistakes is called errors. So usually errors are systematic errors and random errors. What about systematic error? Anything error that happens systematically, that is systematic error, but random error is not customizable and not removable. This is customizable and removable. The systemic errors can be removed, but the random error, what happens? Like suppose we are measuring something through the scale, and we can say that there was something like, if we need to write 7.6 centimeter, and if somehow we can just forget to give it the point, then it can be 76 centimeter, or even if we got it like 5.2, if you just put another 2 after that, then it might have some variations into the true value. So as we don't know the true value, we measure the approximate value or measured value including the errors. And that is why we need to remove those errors by calculating these. And that is why in this video I'll show you what is relative error and what is absolute error. Let's think about the picture that I'm just giving it here. In this picture, let's think that this scale is given a centimeter unit. So this is 0, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Think about that the points is given that in millimeter. So we know that in 10 millimeter is actually 1 centimeter. And suppose the blue one is given a substance and we are measuring it. Now you see that from the starting point of 0, it ends in between 7 and 8. In between 7 and 8. So now you would think that this is 7, 8, 9 and 6. Suppose this is this bigger one, bigger picture of this scales. So this is 6, 7, 8, 9, and the last part of the material or the things that we are measuring has ended up here in between 7 to 8. So what is our conclusions about the measuring the length of the scale? Do we say that it is 7.5 millimeter? Or we can say that this is 7.65 millimeter, or can we say that this is 7.48 millimeter? What can be the exact value of this point? Because we are measuring as a length. So suppose it's coming up millimeter, because we know this is given a millimeter unit. But the last part of the portions is coming up in between 7 and 8. So as we know that this is the 1 millimeter distance, so we can say that this is 7 plus minus 0.5 millimeter. And this is the value that we express. And this 7 is the measured value. And this 0.5 millimeter is the absolute error. So this is actually the absolute error. So what is actually absolute error? You see that absolute error is the magnitude that actually shows the differences between approximate value and the true value. So the approximate value and the true value, the differences is that we can say that this plus minus 0.5 millimeter from 7, it can be 6.5 millimeter. It can be 6.5 millimeter to 7.5 millimeter. So that is the variation that we get. So in this variation, the length would be in between. So we are giving a range, and that range is the approximate value of the length of that substance that we are actually measuring through the scale. And this is the approximate, the absolute value. So what is the definition? We simply can say that absolute error is actually the differences, the magnitude of differences between approximate value and the true value. So when we will measure about a relative error, it means that is in relation between the two errors. So when we will study about relative error, think about this one. This 0.5 millimeter is the absolute error. So the relative error is actually divided by the absolute error upon the measured value. So we can say the absolute error from this information is 0.5 millimeter divided by 7. So if we divide 0.5 divided by 7, we get like 0.5. Let's find a calculator. So we can say that 0.5 divided by 7 is 0.071. So that is 0.071. Now if I want to express these errors in percentage, then we need to do it 0.071 times 100%. So as we know that we are multiplying by 100, we can say that we can shift this decimal into 2 point right side. So that should be 7.1% is the relative error. So we are expressing it in percentage. So the percentage error is 7.1. So based on this example, that 7 millimeter is the measured value, but the range is plus minus 0.5. So this 0.5 is the absolute errors, and this is the relative error. So when we can find the absolute error, we also can find the relative errors, because the relative errors is nothing but the relationship upon absolute error divided by the measured value. Okay? Let's take some examples of these. This is the easiest one that I have explained it to you, and think about how to do it. Suppose we are measuring something, and the result came out like 5 times we are measuring. Suppose first time we got 6.1 centimeter, second time we got 6.2 centimeter, third time we got 6.3 centimeter, fourth time we got 6.0 centimeter, and the fifth time we got 6.4 centimeter. Suppose we are measuring something, and this is the value. And if you understand a single example, and if you got the concept of it, I think it would be much more easier to find the other values on the next level. So these are the 5 times measured value of something we are measuring. So think about, this is x1, the first value, the second observed value, the third observed value, the fourth, and the fifth. So if I have the 5 times values or the observable quantities of anything, then what should I take? I should take the mean value, and this mean value is x bar is actually x1 plus x2 plus x3 plus x4 plus 5. So there are 5 observations, so I need to divide it by 5. Okay, so it means the number of observations I got will divide by the numbers. So simply it would be like 6.1 plus 6.2 plus 6.3 plus 6.0 plus 6.4, and if I divide it by 5, the division would be 6.2 centimeter. So this is the mean value, the mean length of the things, that is mean, or you can say x mean. So this is actually x mean, the arithmetic mean. Now you see what is the absolute value, absolute errors here. We are finding the arithmetic mean of the length is 6.2 centimeter. But at first, when I took the first observation, we got 6.1, we got 6.2, we got 6.3. So what is the errors are there? To find the errors, we need to find the del x, that is the differences. So the del x is the differences of what? Of the value and the mean. So simply, if I say the differences, it doesn't mean that x mean minus x1 or whatever, x1 minus x mean, whatever you say, that if you say that x bar minus x1, we want to see the differences, the magnitude from this. So think about the first one. So del x1 is the first deviation. So it is 6.2 minus 6.1. See that this one. So 6.2, this one is x bar, minus 6.1 is 0.1. And then secondly, then x2, 6.2 minus x2, that is 6.2, would be 0. Then del x3, 6.2 minus 6.3, that is minus 0.1. Del x4, 6.2 minus 6, that is plus 0.2. And del x5, that is 6.2 minus 6.4, that is minus 0.2. Now I have the idea of the deviations from the mean value to the measured value. Now what should I do? Now I need to find the deviations and the mean of this error, and that is del x bar. So when I should find the del x bar, that is actually the positive del x1, the positive del x1, because we should not take the negative value, del x1 plus del x2 plus del x3, like this, and we need to go in this way, plus del x4, del x5, and divided by the number of observations. So this bar means we don't need to hesitate with the negative values. We just need to find the values, that what is the differences in between. So this is 1, 2, 4, 6. So together it would be 0.6 by 5. So 0.6 divided by 5, that should come like 0.6 divided by 5 is 0.12. 0.12. And this is mean absolute error. This is actually mean absolute error. So now what we can actually say, that what is the value, measured value. We took 5 times observations from that and we got different values. We took the mean and we just find the deviations from the mean and the observed value, and we got the mean absolute error. Now I can express that the length of that substance or that things that we are actually measuring is 6.2 plus minus 0.12. So So we can say this 6.2 is the mean value. That means the approximate value. And this is the measured value. And then the 6.2, we know that we measured it, but the range can be positive 0.12, negative 0.12. So if I find the length of this matter is in between, if I divide it, if I just plus it, then it will be 6.32 centimeter. And if I get divisions like that, 6.2 minus 0.12, it will be 6.08. Is it 6.2? No, yes, 6.02 to 6.30 centimeter, and this should be the range. So the length of that substance would be in between this, and this is the absolute error. And if this is the absolute error, what is the relative error? The relative error is is absolute error divided by measured value, and if you want to express it into 100 and percentage, then it should be 100%. Now we find the absolute error is 0.12 and the measured value is 6.2 times 100%. So it will be 12 divided by 6.2%, and then it will be like, okay, 12 divided by 6.2, which is 1.93%. So 1.93% is the relative error, and which is very low, 1%, I mean nearly 2%. So 1.93% is the relative error, and previously we got 7.1%. So this is a very simple example of the relative error and the absolute error. So whenever you can find the value of absolute error, we need to divide it by the measured value, and then we got the relative error. I can give you another example. So you got it, 5 times observations, and then we just got the positive deviations. We don't need the negative part to find out the relative error. So I can give you another example that in case of measuring the area of something. So how do we measure? Suppose there is a square substance, and it was said that the length is 10 centimeter. Think about it, 10 centimeter. So as it is square, all the arms will be 10 centimeter. And if it is said that the absolute error of this measurement is 10%, then what should be the relative error when we'll measure the area of the substance? So now you see that the 10% error, if it is 10% error, so now you see this is 10 centimeter is given the length. So the 10% of 10 centimeter is actually 1. How? Because you know that 10 centimeter times 10 divided by 100. So that is 1 centimeter. So we got 1 centimeter absolute error from both sides, as the 10% is the absolute error. So the length can be 10 centimeter plus minus 1 centimeter. Either the both side length can be 9 centimeter or it can be 11 centimeter. 11 centimeter. So first time when we'll measure the area of that substance, then we find it was given 10 centimeter times 10 centimeter. So it should be 100 centimeter square. But as it is given the 10% error, so if we take the smallest one, that means 9 centimeter, so the area would be 9 centimeter times 9 centimeter, which is 81 centimeter square. And if we take the bigger one, then it will be 11 centimeter times 11 centimeter, which is 121 centimeter square. Now you find the deviation. If we find the smallest deviation, that is del A1, that is A minus A1, that is, if I just shifted 100 minus 81, it should be 19 centimeter square. But if we see the biggest deviation, that del A2 is about A2 minus A, which is 121 minus 100, so that is 21 centimeter square. Now we need to find which one is the biggest deviation, 19 and 21. So we know this 21 centimeter square is the biggest. So as we know, 10 centimeter length was given, including 10% of absolute error. We find area previously 200 centimeter square, and considering the errors, we find the area change happens is 100 centimeter square, and now we got it 121 centimeter square. So the differences between this area is 21 centimeter square. Now to find the relative errors. Find the relative errors is the changes. The absolute error is 21 centimeter square. 21 centimeter square upon the measured value is 100 centimeter square. Now if we express it into percent, it should be 21%, and this is the relative error. So when we will measure the area of something, we measure the area of the substance which is given 10 centimeter. Now if it is given 50 centimeter, it is given 30 centimeter, and the percentage is 10%, then we need to count that what is the deviation of that percentage upon this length. If it is given 50%, we need to find what is the 10% deviation of that 50%. And if it is given 30 centimeter, we need to find what is the deviation of 10% of that 30 centimeter. And then we need to find the smallest one and the biggest one. And we need to see the changes or the variations among the values. And we will take the bigger one. And we will consider the bigger one. And then after considering the bigger one, we will find the absolute error. And whenever we can find the absolute error, we can also find the relative error. Simple. It is getting easier for you. Now, if you want to measure the volume, I mean three-dimensional, I mean three lengths together, we are measuring here two lengths. Now, if we measure three different lengths, then the scenario would be same. If you understand the concept, then I must say that it will give you a good feeling, because it's all about mathematics, it's all about calculation, and we used in our daily life these calculations, this measurement. We are doing this mathematics willingly or unwillingly in our brain. So now if you see that, if you think about a cube or something like that, and think about the space. So it is given the length of that rectangular is 10 centimeter, the breadth is 5 centimeter, and the height is 4 centimeter. Now if it is said that the absolute error can be 0.5 centimeter in case of length. So it could be the length plus minus 0.5 centimeter is given. Now you see that considering this 0.5 centimeter, previously if you find the volume of that rectangular is length times breadth times height is 10 times 5 times 4 is 200 centimeter cube. 200 centimeter cube. And now if we find the second volume considering the errors. So now you see that 10 centimeter, if you find 0.5, 5 centimeter, 0.5, 4 centimeter, 0.5, you will get 9.5, 4.5 and 3.5. So this should be 4.5, 3.5. So this is the minimum value. And if I add all these, then we'll find the maximum. So what can be the maximum? 10.05, 4.5, 3.5. So it's the minimum. It's the minimum volume can be 9.5 times 4.5 times 3.5. So this is altogether 149.625. 149.625 centimeter cube. And the V2, which is the maximum, including the errors, it can be 10.5 times no, this is 5, 4, so it should be 5, it should be 4, so 5.5, 4.5, so each one is 4.5, 3.5, that is okay. And now if I say that this is 10.5 times 5.5 times 4.5, now it should be 259.875 centimeter cube. So previously we find 200 centimeter cube is the measured volume. Excluding the absolute error, we got 149.625. Including that, I mean, when we add these errors, we got 259. So now which one is the bigger? If I just divide it like 200 minus 149, it should be like, what should be? It's 50.375. So V minus V1 is 50.375. This is the minimum differences, all the deviations. And secondly, V2 minus V, it should be 59.875. Now which one is the bigger? 50.375 or 59.875? Definitely 59.875. This one is the bigger differences. So now this is my error, absolute error, and this is my measured value. So the relative error would be 59.875 upon 200 times 100%. So it should be 5987.5 divided by 200, that is 29.393%. So this is 29.93% is the relative error. I hope you understand what I explained in this video. If you just watch the whole tutorial with full concentration, and I'm giving it according to your books. Students of English versions, Cadet College, wherever, from which part of the world, I don't know, but if you're watching this tutorial, just make sure that the examples are endless. I'm just picking the examples from the books which is already there. So I'm just giving you that idea only that what can be the differences in between. At first we need to measure value based on the data, and then whenever we add or subtract the absolute error, we will find the minimum one and the maximum one. We will cover the maximum one, and that can be the maximum error. So considering that maximum error, that is absolute error, we will find the relative error, and we can also express these errors in percentage. So that is clear. I hope it's clear. So hopefully remember, absolute error is the differences, the magnitude of differences between approximate value or the true value. True value we don't know, but absolute value. And then relative error is the absolute error divided by true value, and if you want to express it, just multiply by 100%. So that's all for now, and in the next video I'm coming up with the explanation of how to measure the length from using vernier scale and slide calipers. So see you then. Take care, stay well, stay immune. Bye.